Hi, Algebra 2. Welcome back. So this is the second lesson, Unit 1.2 that we're going to talk about. And so today we're going to look at functions and then domain and range also. And then we'll look at, again, some spiral review. All right, so functions and non-functions. So functions, looking at a graph, um, we can look at ordered pairs. We can look at an actual graph, the shape of the graph. We can also look at what's called a mapping also, if you're not familiar with that term. All right, so in this first graph, these are ordered pairs. I'll just call it number one. So you can see one of the dots is -1, +1. Another one's at 0, 2. Another one's at 1, -1, and 3, 0. And so these are just ordered pairs, and they're just plotted on a graph as dots. And so typically what makes a function is if it can pass what's called the vertical line test. Okay, vertical line test. And so you can look at each of these, and if I were to draw a vertical line, so let's see, each vertical line that's drawn is only going to intersect one of these dots each time. So there's not a vertical line that can be drawn and it intersects two dots at the same time. Okay, and so that's, oops, leave my eraser. And so that's typically how a function is a function, by looking at its graph. All right, and then we can look at all these other ones. Again, we can see, each one of these vertical lines only intersect the graph one time. It's not going to get, you're not going to get an intersection point of more than once for each vertical line. Okay, and same with your other graph. All right, and we can also look at the first one again, looking at each of these ordered pairs. Again, we have -1, 1. We have 0, 2. That one's at 3, 0. That one's at 1, -1. And so looking at ordered pairs, if you look at each of the x values, so each of the x values that were used to plot this, none of them are repeated more than once. Each one is represented one time each. And so that's typically also what makes something a function. All right. And then, so that takes care of the ordered pairs. Our two graphs, each of those vertical lines that we were to draw will only intersect the graph in one place. Now, in this last one, this is called a mapping. All right? So a mapping has values on the left side and values on the right. And the left side values are input values, and the values on the right are called output values. And each of these have arrows going from the left side to the right. And these can also be used as ordered pairs. So you have a -3 paired up with a -1. You can see the arrow, right? So if I were to write out the ordered pair -3, -1, then there's another ordered pair -1, and it's being paired up with -2, and 1 is to -1 and 2 is to 0. All right, and so you can see each of those. I'm not going to write them all out, but each of those ordered pairs, if you look at the x values again, each of them are only going to be represented one time. None of them are going to repeat more than once, and that's because if you look at the arrows, you don't have any numbers on the left side with two arrows coming off of one of those numbers. Okay, so on the left side, if you have two arrows coming off of one of the numbers, then it's not a function. All right, so now if we look at the non-functions and why these are not functions, if we were to draw vertical lines, we can see that none of them are going to pass what's called the vertical line test. So on the ordered pairs, the dots, I can see if I were to draw a vertical line right here, I'm going to pick up 2 points exactly right on top of each other. All right, so you can see it again. That vertical line would intersect 2 points at the same time. And again, the reason is because if you were to write the ordered pairs out, it's -2, 0, -2, 0. And then this one right here is at -2, -3. You can see the two x's repeated at -2. If we look at this circle, It doesn't pass the vertical line test either, because I can see there's an ordered pair here and another one right here, directly on top of each other. A vertical line would actually intersect an infinite number of points directly on top of each other. All right, so you can see because it's more than one point would fall on that line, that vertical line, it's not going to be a function. And then the mapping again, really where it fails is this location right here. And that's because positive 1 is being paired up with negative 1, and positive 1 is also being paired with 0, and you can't have that for a function. Right? So just so you can see, given a mapping, given a graph, or given ordered pairs, or points on a graph, what makes something a function. All right, so come down here. So function, we could, given ordered pairs, the x values are not allowed to repeat. Given a graph, no vertical line can intersect more than once. And then giving a mapping, 2 arrows from one number that's on the left side don't point to 2 different numbers on the right. Okay, so you can't have that. So function notation, we use this f of x notation, f of x. It's not f times x. All right, so it's just another way of representing the y values of a function. So anytime you see f of x, you could replace it with just y. We can use this notation when evaluating a function written as a graph, a mapping, ordered pairs, a table, equation, lots of different ways of writing a function. So what we're going to do is look at 3 different forms. So we have a graph, an xy table, and an equation. And we're going to practice evaluating for 3 values, f of negative 3, f of 0, and f of positive 3. Okay? And so we're looking at the columns, and so we can see how to do this. All right, so we're going to do the graph one first. So it says evaluate for f of negative 3. Find f of negative 3. So we want to understand that the number inside, the negative 3, that's an x value. Okay, so just so we can remember, this is our x. And what we're trying to find is its y value. Okay, so when x is negative 3, what is y? And so we can go on our graph, go to negative 3 on the x-axis. Okay, so negative 3, negative 1, 2, 3. Here's negative 3 on the x. And you're going to go either up or down to intersect the graph. Okay, so we know that we're going to have to come up here to find its ordered pair. It's right there. That ordered pair is at negative 3, 2. So that means when x is negative 3, right up here, when x is negative 3, y is positive 2. Okay? So we've got to find a point on the graph that uses negative 3 as its x value. So let's do number 2, f of 0. So we've got to go and find 0 on our x-axis, and then go up or down to intersect the graph. Okay, so here's 0. Well, we know we're going to have to come up, and it's going to be right there. All right, and that ordered pair right there is 0, 5. So that means when x is 0, y is 5. All right, and then let's do f of 3, so f of positive 3 this time. So now we have to go to positive 3 on the x. So 1, 2, 3. And then we have to go up or down. And this time we have to go down, because that's where the graph is. And that ordered pair is at positive 3, negative 2. Positive 3, negative 2. All right, so that's how you use a graph. All right, so now to do an xy table, it's actually pretty easy, because again, remember, negative 3 is the x, and you're trying to find the y that corresponds to it. So when x is negative 3, here it is right here, when x is negative 3, y is positive 8. All right, f of 0, when x is 0, y is 0. And when f of 3, when x is positive 3, y is negative 5. All right, and then given an equation, we're going to use substitution. So we want to find f of negative 3. So again, this number inside the parentheses is our x, and we're trying to find the y. So f of negative 3 would equal 2 times negative 3 minus 10. Now we use order of operations to simplify, and so that would be negative 16. And then f of 0, again, we're going to put 0 in, f of 0. So 2 times 0 minus 10, that's 0 minus 10, which is negative 10. And then we have to find f of 3. So I'm going to run out of room here, so I'll do it up here. F of 3. So 2 times positive 3 minus 10. 6 minus 10 is negative 4. Right? So each of these, it tells you at the top, but the graph, the table, and the equation are not related to each other. That's why you're getting different values for each of these. Right? So you just want to understand, how do you evaluate a function given its graph, given a table, or give an equation. All right, so again, at the top, the domain are you're looking at what vertical lines are going to intersect the graph, and you're going to always move left to right when we talk about domain. It's always left to right. Okay, kind of like when we did interval notation. Okay, you're going smallest number to biggest number when you write it. It's always left to right. Range, we're always starting at the bottom and going up to the top. We state our range. All right, so let's go through each of these. We're going to first state, do we have a function? Then we'll state the domain and the range. So if it's a function, it has to pass the vertical line test. All right, so every vertical line that's drawn has to only intersect the graph one time each time. And so we can see that every vertical line will only intersect one time. So yes, this is a function. Now when we state the domain, okay, again, we're looking at what vertical lines intersect our graph as we move left to right. So always think of, if you were to put a vertical line where negative infinity is, that's on the furthest left, you want to ask yourself, does that vertical line, will that vertical line intersect the graph at any time? Well, no, it won't. And that's because this point right here is the furthest left that the graph is. There's nothing that's further to the left than that point right there. So as we take this vertical line that we drew, that's where negative infinity, we're going to start to slide it to the right. And we want to know, when does it first intersect the graph? Okay, well, we can see that the first time it intersects the graph, I'll draw it right here, is right there. That's the first spot that it intersects. So what we have to do is give the x value of where it intersects our graph. So the x value would be negative 1, 2, 3, 4, 5, 6 at negative 6, right? And because it's a closed circle here, you can see on the graph, okay, it's closed right there, then it's going to have a bracket. So we're going to go bracket negative 6, and then we're going to take this vertical line and keep sliding it to the right. I'll just keep sliding it, okay? And as long as it continues to intersect the graph, then you're good to go. It's still every one of those x values are going to be part of the domain. All right, so it's going to continue to hit all the way to this spot right here. It's not going to hit over here because the graph stops. So we just have to know, what is the x value for that, that last point. So the last point that it hits looks like 1, 2, 3, 4, 5, positive 6. And then we're going to use a bracket again because of the closed circle. So always go left to right when you're talking about domain, because you have to go smallest to biggest. All right, now when we talk about range, we're going to go bottom to top. So here's where negative infinity is, down here. That's the lowest spot that you can go, is where negative infinity is. So now the question is, does the graph and that horizontal line that we just drew, will those two intersect each other ever? Well, no, they won't. So now what we do is we take this horizontal line and start to slide it up. And as we move it up, we want to know, when does it first intersect the graph? Well, it's first going to intersect right there. Okay, that horizontal line will first intersect the graph. So we need to know, what's the y value of where it intersects? Well, the y value is going to be 0. And we're going to use a bracket because of the closed circle. Now we're going to keep sliding this horizontal line up until it reaches a maximum value. We can see the highest point that it's going to go is right there. And so we just have to know what is that highest point. So what's the y value? So we just count up. 1, 2, 3, 4, 5, 6. Looks like positive 6. And it's going to have a bracket. All right, so let's do number 5. So again, we have to do the vertical line test, and we can see that every vertical line that intersects our graph will only intersect one time. So yes, this is a function. Okay, now we're going to do our domain, and we work left to right. So if I were to draw a vertical line on the negative infinity side, we want to see, does it intersect our graph? And no, it doesn't. So we have to take our vertical line and start to slide it to the right. Find out when does it first hit. Well, it first hits right there. And so we need to know what is that x value, because domain deals with x. What's the x value that hits that graph? So it looks like 1, 2, 3, 4, 5, 6, 7, negative 7. And then we're going to take that vertical line and continue to slide it over. Okay, keep sliding it. Continues to hit every time. This is the last spot that it'll hit. Okay, and so we need to know what's the x value. So it's 1, 2, 3, 4, 5. Positive 5. Now positive 5 is going to have parentheses, and that's because of the open circle. So everything up to positive 5 is part of the graph, but not 5. All right, so let's do our range. Okay, working bottom to top. All right, so we're down here at negative infinity again, and we're going to start to slide it up. Find out when does it first hit the graph. Okay, it doesn't hit at negative infinity. I'm going to keep sliding it up until we hit right here. This is the first spot, or the first horizontal line, going from bottom to top that intersects. So we need to know what is that y value. So it looks like negative 3, and it's going to be a closed circle. So it's a bracket at negative 3, and then continue to slide it up. All right, and so it looks like the highest that we're going to go to is right there, and that's positive 1, and it has an open circle, so we're going to have a parenthesis. All right, number 6. Okay, is this a function? Well, it looks like it's a vertical segment, vertical line segment, and if I draw a vertical line through a vertical line, it's going to intersect more than one time. So no, this is not a function. Now the domain, again, is if we work left to right, okay, here's our negative infinity that we start, and it doesn't hit, and as we slide it over, we want to know when did it first hit. Well, it's only going to hit right there at that one spot. So we just have to know what is that x value. So 1, 2, 3, 4, 5, negative 5. All right, so it does hit at negative 5. Oops, put it in another row. Okay, so negative 5 is the only value that will work, and we'll use brackets on that. All right, and then range. Okay, working bottom to top, so we start at negative infinity. It doesn't hit at negative infinity, so now we have to slide it up. So we want to know, when does it first hit? Well, it first hits, looks like we're right in there at negative 2. The y value is negative 2. But because of the open circle, we have to use a parentheses. Now we're going to continue to slide that horizontal line up until we reach a maximum height, which is right there. And so that y value is 1, 2, 3, 4, 5, 6, positive 6. And it's going to have a parentheses, again, because of the open circle. Right, 7. We have a circle, and so we can see that a circle is not going to pass the vertical line test. So no, this is not a function. Our domain, again, we start on the left side and slide that vertical line over. When does it first hit? Well, it first hits right there. And so that x value is 1, 2, 3, 4, negative 4. And because our circle is a closed circle, it's going to have a bracket at negative 4. And then it's going to continue to hit all the way to right there. That's the last spot it's going to hit. And that x value is positive 4. Again, we'll use a bracket. right? And then when we do our horizontal lines to find the range, okay, it's first going to hit down here. It's the lowest. That's 1, 2, 3, 4, negative 4. And then we'll slide it up, and positive 4 is going to be the highest. All right, number 8. Okay, is this a function? Well, if I draw a vertical line right there, it's going to intersect in 2 spots. So no, this is not a function. Finding the domain, if I work left to right, again, I start on the left side and slide that vertical line over and find out when does that vertical line intersect the graph. When does it first hit? Well, it first hits right there, and that x value is 0. We're going to do a bracket. Then we slide that vertical line across left to right. Okay, so moving it to the right, it continues to hit, and now we're all the way over here at positive infinity. And because of these arrows, that means that this keeps going forever, and they will intersect. And so that vertical line is as far to the right as you can go, which is at positive infinity. And then we use parentheses. All right, the range, we go bottom to top. Okay, so we're down here at negative infinity. I think negative infinity is down there. And it doesn't hit right there, but if we take this arrow and we continue it down, they will intersect, right? And so we do intersect at negative infinity. And then as we slide this the horizontal line up, it's going to continue to hit everywhere, okay? Now we slide it up high enough, let's say we're up here. That's positive infinity. Well, this will intersect because this keeps going up forever also. Okay, so they will intersect at negative infinity all the way up to positive infinity. All right, number 9. All right, is this a function? Yes, it is. It does pass the vertical line test. The domain, okay, working left to right. Here's our starting vertical line on the far left. It doesn't intersect our graph, and so we slide it over. It's first going to hit right here at 0. Now it's going to have a parentheses because of the open circle. And it's going to continue to hit as we slide it across, even over here at positive infinity, because the arrow makes it go forever. Then our range. Okay, we're down here at negative infinity to start. We slide it up. It's not going to hit anywhere until right there. That's the only place it's going to hit. And that's at 1, 2, 3, 4. So positive 4 is the only value for the range. All right, number 10. Is this a function? Well, it's just a horizontal line segment. Yes, it is. It will pass the vertical line test. The domain, we're going to go left to right. Okay, and I can see right there is where it's going to first hit. That's at negative 3 with the parentheses to the open circle. And then right here is where it's last. Okay, that last vertical line is going to intersect where it ends. So it's 1, 2, 3, 4, 5, and this is going to have a bracket. So negative 3 to positive 5. And then our range, we're going bottom to top. And it's not going to hit at negative infinity down there. And we're only going to hit at one spot. Now it looks like at negative 1. And just use brackets on that. It's just one number. All right, 11. Something right. All right, so this is a function. It does pass the vertical line test. The domain, working left to right, looks like it's first going to hit right there. And it's a closed circle, so we'll use a bracket. And so that x value is 1, 2, 3, 4, negative 4. And then the last vertical line that will intersect is positive 2. Use a bracket. Okay, the range, we're going to go bottom to top. The first horizontal line that's going to intersect is at -2 with a bracket. The last one is right there. It's a little lower. 1, 2, 3, 4. And in the bracket. So -2 to +4. Right, so again, domain, always work left to right. What vertical lines are going to intersect the graph, and you look at the x values. Okay, the x values on the x-axis, and then range bottom to top. What horizontal lines are going to intersect the graph, and you're looking at the y values. All right, so number 12, this is a function. Domain working left to right. So the left vertical line is right there. That looks like 1, 2, 3, -3 with a parentheses. And the last one, as you move it to the right, is at 1, 2, 3, 4 with the parentheses. And then our range, working bottom to top, the horizontal line that first hits, that's at 0, and that's going to be a bracket. The last one that's going to hit is right up there, and it looks like 1, 2, 3, 1, 2, 3, 4, 5, and that's going to have a parentheses because of the open circle. All right, so that's how you identify a function, do the vertical line test, and then the domain and range, write it in interval notation. All right, and then let's go ahead and do a little spiral review of simplifying expressions. So when we simplify, we're trying to combine like terms. Like terms have the same base, so same variable. Okay, so look at the x's or the y's. And then they also have to have the same exponent. So x squared can combine with x squared. X to the first can combine with x to the first. X to the third cannot combine with x to the second because they have different exponents. X's cannot be combined with y's because they have different bases, different variables. All right, and then once we find the like ones, we can add or subtract the coefficients. Coefficients are the numbers that are in front of the variables. All right, so for example, number 1, 7x plus 4x. They both have x's. They're both raised to the same exponent, so we can add the coefficients 7 and 4. And so that's 11x. Okay, not 11x squared, but 11x. Number 2, we have a 3n squared, and there's another n squared, -1n squared. So we can combine those two together. So that's going to be 2n squared, and then plus n. And there are no more like terms, so you can't add n squared and n together because they have different exponents. Number 3, we're going to go ahead and distribute. That means multiply inside first. Okay, so -2 gets multiplied to the x and the 1. So that's going to be 2x plus 2. Then we're going to distribute the -3 in. So -3x plus 12. Now we can combine like terms. So 2x and -3x can be combined together. That's -1x, or -x. Then the 2 and the 12 can be combined because they're just numbers. So 2 plus 12 is 14. And that's as far as you can go. So you can't combine variables and numbers together because they're not like. All right, and then number 4, we have a 5x and a 6x. Those can be combined. That's 11x. And then we have a -2y and a +5y, and that's plus 3y. And that's as far as you can go on that. All right. So that's the end of the lesson. Good luck with homework. If you have any questions, don't hesitate to ask me. Thank you.